So hopefully that's a bit of a taste into what index notation really looks like visually. But what's the sort of mathematical way in which we represent these? So index notation is just a way of representing numbers. In the same way that when we first learnt about addition, right, we can have repeated addition. So for example, if I have, 2 plus 2 plus 2 plus 2, let's go again. So hopefully that's a bit of a taster in terms of what index notation actually kind of visually looks like. Well, what about the mathematical representation? Well, it's just another way of representing numbers being multiplied by themselves. Now, why would you want that, you may ask? Well, let's think about addition, right? When the first time you learnt addition, you think, hey, I can just add these things multiple times. That's fine. 5 plus 5 plus 5, 15, right? What if you want to do this 10 times? Do you really want to write this out 10 times? Probably not, right? So another way of writing that is 5 times 10, right? Which gives me 50. This sort of shorthand way of writing repeated addition using multiplication is a much more effective way or efficient way of writing this. In the same way, indices are the same, right? So we had a look over here as an example. So 2 times 2 times 2 times 2, that's the same as, and if you check on your calculator, you get 2 to the power 4, which is also the same as 16, right? And so these different ways of representing them, we call them different things. This sort of stretched out version, we call the expanded notation. This here we'll call the index form. And like I mentioned over here, this is your result or answer. It may be called the basic numeral, okay? So that's the different ways we can represent the same thing. Now I just want to dissect this a little bit more. Let's draw a little big one over here. Because each of these has a different name as well, each of these parts, right? So this, as we've talked about, is an index, but it also has another name. So we can call it the power you may have heard about, or a little fancy term, exponent is another way of talking about it. Here, this one we call the base. So don't drop the base. Okay? So that's a little way of just trying to think about all these different types of notation here. Yeah? Okay. What are the questions going to ask us? So these first couple of questions will just be getting us familiar with the terminology and actually what these mean, right? So write the following in expanded form. What is expanded form? Well, it's when we sort of stretch these out so we can actually understand what x cubed is representing. It's the same as x times x times x. You may notice that there's a lot of x's going on here with the x variable and also the multiplication symbol. So what I'll tend to do is try and emphasize that curve, but also I'll make the multiplication symbols like a little bit smaller just to represent that, right, in that case. Okay, next one. AB to the power 4. You can have the same thing here with this sort of variable with 2 letters, right? So we can say that that's just AB times AB times AB times AB, right? And same as over here, 6m squared n to the power 4. Doesn't matter which variables are attached to you. Look closely at what the base is and what the power is. That's how we'll write this out in expanded form, right? And so these, just like in algebra, usually these are all multiplied together because they're next to each other. Okay? That's how you could write the following in expanded form. So here's a few more for you to try. You can pause the video and have a go at them, but I'll go through them as well. Just to note, these ones are a little bit different because they're numbers this time. So what that means is we are going to write them out in the expanded form, but I'm also going to find an answer. I'm going to evaluate that, right? So 3 cubed, we know that's 3 times 3 times 3. Remember, it's not just 3 times 3 there, right? This is saying how many times you're multiplying the number by itself. And so when you put that in your calculator, you can work it out. That's giving me 27. Right? All right, next one, -5 to the power 5. Be careful here because with negative values, can you see how they're surrounded in brackets? So that means that this inside expression is being multiplied by itself 5 times. And it includes the negative, right? So the way I'd write it out is I have to make sure I include that negative, yeah? Which means I have to write a lot of operations. So -5 times -5 times -5 times -5. One more time, times -5. This one, can't quite do in my head. So I am going to rely on my trusty calculator. Oh, it's a pretty big number. -3125. Okay, so keep in mind that this is a negative value that's been raised to an odd power. That's really important because when you look at -1 to the power 4, well, you'll notice something slightly different. The number's going to be a lot smaller because, it's just -1. So it's either going to be 1 or -1. But these two, and when you multiply them all out together, they actually give you a positive result because you have an even power here. So that's giving me +1. Whereas when you raise a negative value to an odd power, you can always end up with a negative value there. That's something to sort of keep in mind as a way for you to check your answers. Yeah. Last one, no reason why we can't do these with fractions. And we still want to write it out in the expanded notation, but I'll show you why that's useful. Because when I do this, right, so it's 2/3 multiplied by 2/3 multiplied by 2/3, because it's cubed. And yeah, sure, you can put that in your calculator, but more interestingly, you can actually do this quite easily now because you know with your fraction multiplications, you just multiply across the numerator and then across the denominator. So 2 times 2 times 2, or 2 cubed, that's the same as 8. And 3 cubed, I wonder what that is. Well, funny enough, we've done it over there, haven't we? Power convenient, so that's 8/27 is the result. And again, you can check that on your calculator, which is really cool. So we've looked at converting from expanded form to index form, right? But the whole idea was, that's just showing us what that means. So hopefully you have a good idea of that now, a good understanding. But really the goal was to have a more efficient way of writing these. And so we're going to write these in index form now. And what that means is if I have a times a times a, then I would want to write that as a cubed. And so I know with algebra, any multiplication I can just write next to each other. So that's the same as 2a cubed. Same thing over here. It doesn't matter sort of where these are laid out, if they're together or not, because we know that the order of multiplication doesn't matter. If you swap these around, it's the same meaning. Yeah. So what I want to look at is okay, what are the sort of expressions or the variables that are the same base, right? So these two have the same base, so it'd be 5 squared. Usually put the number first. I've got 3 of these y's, so it'd be y times y times y, or y cubed. And this is a z. Sometimes I'll write a z through the cross, so don't get it confused with that too. But because there's just a single power there, right, I just write z. You could write z to the power 1, but by convention, we typically don't do that. Yeah. Last one, same thing. We can do this with negatives or fractions or whatever you can think of, really. And so the whole idea is that I've got looking for what has the same base and how many times I'm multiplying it by itself. So that this one in this case is -3 on 4 squared, and then I've got 6 on 11 cubed. Okay, and I'm putting them in brackets, so that means they're multiplied together. Yeah. One last problem, which is a slightly different concept, which you might have seen before, but we can write different numbers as a product of what we call the prime factors. So here's the question. Write 24 as a product of prime factors. And so let me dissect that a bit for you, right? So prime, so these are numbers that are divisible only by 1 and itself. So divisible by 1 and itself. And factors, well, these are the numbers that we can break up a single number into and multiply them together, right? So for example, what's a good example? 12 has lots of factors, right? You have 3 times 4, you've got 6 times 2, you've got 12 times 1. Now, these are the factors of 12. But the prime factors, we're putting that together now, right? So we're saying, okay, I want to know the numbers that multiply to 24, but they have to be prime. Okay, so you think about that again, right? So these numbers here, for example, 3 is a prime number, but 4 isn't. Or, 2 is a prime number, but 6 isn't. 1's, well, yeah, it's not really a prime, it's not a prime number actually, surprisingly, but 12 isn't. So how can I do that? Well, what I want to think about is, and I can break it up, and it doesn't matter how you do this, but think about breaking up 24 into its just factors. And again, there's a lot of different options you have here. You can do like 12 and 2, you can do 6 and 4, 8 and 3. What I'll tell you is it actually doesn't matter where you go. So I'm going to do one route, you see if you can do another, see if you get the same answer as me, right? I'm going to do the first one that came to my head. I think 12 and 2 was probably the first one that I thought of. Now, once you get to a prime number, that's when you're going to stop, right? So 2 is a prime number, I'll stop there. 12 is not a prime number. I can still break that up into more factors. I can break that up into 3 and 4, for example. Yeah, I'll just pick one of them, the first one that I thought of again. And then last but not least, 3 is prime, I'll stop. 4, I can keep going. That would be 2 and 2. These are all prime now. And so I'll stop all my branches. And these are what we call now the prime factors. When you get to the end, it doesn't matter how you started. If you started with 8 and 3, you started with 6 and 4, you'll get to this result here. And so to write 24 as a product of its prime factors, I can say 24 is equal to 3 times 2 times 2 times 2. Yep. And again, what do you think I'm going to do here? Well, a nice way of writing this might be saying 3 multiplied by 2 cubed. Yeah. That's how we can write a number as a product of its prime factors. That's a little overview of index notation. Hopefully there's a bit for you to go, and hopefully that made sense. If you have any questions, feel free to leave a comment below.